The section is called right triangle, right triangle. Trigonometry. No, so I'm gonna give you a bunch of formulas before we start. Definitions. So here are the trig functions. Of acute angles, or acute angles. So given this kind of triangle here, it's a right triangle. And let's say that we have a theta, some theta angle over here. We have an opposite side right there. We have an adjacent side to theta over here, and then we have our hypotenuse, right? So sine theta is defined to be opposite over hypotenuse. I'm going to abbreviate it just because so you can fit more stuff here. Cosine theta is equal to, yeah, that's right. Cosine is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. So that will be equal to opposite B over C, right? Just for the extra piece, referring to this triangle here. This would be A over C. This would be opposite over adjacent, right? Now the reciprocal functions, cosecant, right? Cosecant of theta is equal to the reciprocal of sine. So that'll be hypotenuse over opposite. Secant, which is the reciprocal of cosine, that will be hypotenuse over adjacent.
Sir?
Mhm.
I can't read the letters on the first one.
Here?
No, below that,
B over C.
Below that, the one that you just wrote before the last one.
Hypotenuse over, so this is cosecant CSC theta equal
Thank
to hypotenuse over opposite.
Thank you.
Yeah, I see that glare there, but sorry about that. Cotangent. If I had more light in this room, I think it'd be better, but oh well. Cotangent is the reciprocal of tangent, so that will be adjacent over opposite. So this will be C over B, which will be C over A. This will be A over B. Okay. Let me give you the reciprocal identities. And just slow me down anytime. Just let me know. Cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta. Cotangent theta is equal to 1 over tangent. All right, so that's one set of formulas here. And then we have our definitions up here. I'll give you another set of identities or formulas, quotient identities. So the quotient is basically the tangent theta. That's going to equal to sine theta over cosine theta. Cotangent theta is going to equal cosine theta over sine theta. It's just the reciprocal of those guys. Yeah, that's right. That's it for those. Almost done. I like to have all the formulas right before we start. I hope that's okay with you. Pythagorean identity. This is one of the important ones because it's used a ton in many other areas of math, but also it can derive pretty much all of them. So I only derive them for you. That way you have all 9 of them. Technically, they're just going to give you one, but I'm going to give you all of them, okay? So sine squared theta plus cosine squared theta is equal to 1. So this one creates 8 more just by using some algebra. So notice how I can subtract cosine over, create another one. Sine squared theta would equal to 1 minus cosine, right? I think I'm going to put a space just to make it look prettier. Not that it matters. Sine squared theta is equal to 1 minus cosine squared theta. Do you see where that came from? Or this one? Okay. So now if you divide both sides by sine, you're going to get 1 plus cotangent squared theta equal to cosecant squared. If you divide everything by, well, I should probably make this a little smaller so I can fit the other 3. So divide everything by sine. So that'll be 1 plus cotangent squared theta equal to 1 over sine would be right here, right? Cosecant. Now do some algebra. Subtract the 1 over and you'll get cotangent squared theta equal to cosecant squared theta minus 1. Subtract the cotangent and you'll have 1 equal to cosecant squared theta minus cotangent squared. So you create this first set, this first one here, by dividing every single term by sine. And then you just move things around. You create two more. Now divide this all by cosine and you'll create another one. So this would be, yeah, what's up?
Is there supposed to be a theta at the end of that one?
Yeah, there should always be a theta
Okay.
or some sort of variable. Otherwise it's nonsense. Okay. So let's see here. Divide everything by sine. Well, that will give us 1 plus, I'm sorry, cosine. Divide everything by cosine because we did sine first. That will give us tangent squared theta plus 1 equal to 1 over cosine would be secant. Now move this around and you can create two more formulas with algebra. So that'll give us secant squared theta minus 1. Move the tangent, that'll give us 1 equal to secant squared theta minus tangent squared theta. So if you don't have to derive them all, I'm not going to test you on that, but it helps to see how they're derived when we get to like the proof section. But memorizing these or having them on a formula sheet is highly recommended. All right. I think that is all of them. Let me see here. Yeah, I think with that we can pretty much start the problems in the homework. Okay. Any questions about the definitions of the trig functions or the identity stuff?
Not for me.
Okay, let's go to the homework. So the first few questions, just like your last homework, it was just about definition. So I'll let you guys read up on that. Let's get to the problem solving. Okay. So this is from your homework, number 5. So 6.2. I'll try to give you some examples of each type. That way you have some sort of reference, okay? So this is number 5. So find the exact values of the 6 trig functions. Of the angle theta shown. So let me draw you the picture here. So they gave us this picture in the homework. It's a right angle. The little corner means right angle, right? They gave us a 6 and an 8. How do we find the hypotenuse? No, we've done that.
Adjacent over opposite?
Well, that'll give us some of the, that'll give us the, one of the trig functions, but how do we get that missing side?
Pythagorean theorem.
Yeah, we have to go back to our old school stuff, right? You remember? So doesn't matter which one you choose for A or B. I don't really care. So just plug in some numbers. The only thing that matters is which one is the hypotenuse, right? Because there's only one of them. So if I square root both sides, this is 36 plus 64, right? Square root C. What is 36 plus 64? That 100? So yeah, that's 100. So that'll be 10 equal to C. So our hypotenuse is 10. So now that we have it, we can answer the question, right? So who knows what sine theta is?
Eight over 10.
Yeah, it's going to be opposite to theta over the hypotenuse. So 8 over 10. Anybody else want to guess on cosine? So look at your definition. If you don't have it memorized, you got to look at it.
6 over 10?
Yeah, 6 over 10. That's right. And then tangent. I think someone said it earlier, right? That was opposite over adjacent. 8 over 6. We should reduce this stuff though, right? This will be what, 4 over 5? This will be 3 over 5. This will be 4 over 3. Now, what is the reciprocal of sine?
Cosecant.
Yeah, so cosecant, let's do that next because we know that has to be the reciprocal of this guy. In other words, flip the fraction over and we'll have our answer, right? The answer will be this. Or you can use the definition and just find it on the triangle, either way. Then we do secant, because that's reciprocal of cosine, cotangent, reciprocal of tangent. So what is secant?
5 over 3.
Yeah, 5 over 3. And cotangent, there it is. Any questions on how we found the 6 trig functions? Okay, so you can have a few of those on your homework. So number 5, 6 are similar. On 6, you should look. You may need to look up the definition of similar, which will come up with when in the book when you look into it. But it'll be the same thing. You just need to find the ratio. Number 7. 7 is a little bit different, so let's do that one. Is it okay if I turn the page? Okay. So number 7 says, sketch a right triangle corresponding to the given trig function. So what they do is give us cosine. And they ask us to find the rest. But first, and find all 6 trig functions. All right. So let's draw our triangle. So what is cosine defined as?
Adjacent over hypotenuse.
Yeah, so if I put theta here, then that means adjacent is right here, right? Which then means this has to be hypotenuse. All right, sorry, I got distracted here. So we need the missing side, right? So we know that our formula, a squared plus b squared is equal to c squared. We have c. We can say that that is our b, I guess. So we need a, we have b. Okay, so I'm going to subtract 15 to the right so we can solve for a. I don't know what 15 or 17 squared is, so I'm not going to worry about it right now. I just know that I need to square root both sides. Whatever number that is will be square root as well. Let's see. It's time to where's my calculator? Oh, here it is. Okay. The second square root, let's see here. Just out of pure laziness, I'm going to just punch it in and find out what it is. Looks like 8. So a is equal to 8. All right, so now we have all sides. So what is sine? What is cosine? We got that one, so that's cool. What is tangent? So this one, just use the triangle now that we've solved for a, right? It's not a big deal. Opposite over hypotenuse, it's right there. Yeah, opposite over adjacent is tangent. So opposite over adjacent And then using our reciprocal formulas or identities, we know we can just flip these guys over. So cosecant is a reciprocal. Secant is this reciprocal. Cotangent is this reciprocal. And I don't know if you guys remember, SOHCAHTOA helps me remember what is what, right? So sine theta is OH, opposite over hypotenuse. Ka for cosine is adjacent over hypotenuse. TOA, tangent, is opposite over adjacent. If you want to use that to help you, that'd be great, but you don't have to. Any questions on number 7? Did you see how it's the same thing? Even if you have one trig function, you should be able to find all 6. All right, let me find the next question then. All right, numbers 8 and 9. Number 8 is the same thing, so we'll skip that. 9 is 9 and 10 are really just punching in numbers into a calculator. Just make sure you remember if you're in radians or degrees, otherwise it'll come out wrong. You guys familiar on how to change your calculator to radians or degrees?
No, can you show it real quick?
So if I mean, I only have the 83 and the Pro. I mean, I can show you on those two. Let's see. Where is it? Which calculator do you have?
The TI-83.
Okay, so it'll be the same.
I have
So
the Pro.
Which one? What's up?
I have the Pro.
Okay, we'll do both then. So it should be very similar. For the 83 or 84, it's the same thing. You just go to mode, and then you go down and find wherever it says radians or degrees, and you just toggle and press enter. Okay, that's it. So just go to mode, find what you want to do, go to, and press enter on it. If you have 36 Pro, I think it might be similar. Hit mode. Scroll all the way down. Oh, it's at the very top. Degrees, DEG, RAD, and gradient. So yeah, just change it at the top. Radian is degrees.
You know, your syllabus says that you're only allowed to have the Pro.
Yeah, that's technically true, but I don't mind using that 83 or 84. This one just does everything you need except graphing. I would recommend this one more because it's cheaper. But if you have an 83 or 84 already lying around, I don't mind if you use it. But I know the department changed it on the syllabus recently and said they just to use a 36 Pro, but.
So since I have the Inspire, can I use it or do I need to just keep my 83?
As long as it's not Inspire CAS, I don't mind you using it.
I have no idea. It's blue.
It should. Does it say CAS anywhere on there?
I don't know. I'm not at my house.
Yeah, as long as it
Well, I'll
doesn't
have
say
to-
that, it'll be fine.
Okay.
To double check, sir, what is the purpose of changing it to radians?
Oh, okay. Let me show you. So let's say so right now mine's in degree, right? So if I were to use sine and plug in 30 degrees, I would get my answer, 1/2. But if I need to plug in like pi or something, I have to go in there and change to radians to use pi. So then I go, okay, cosine of pi over 2, which is equivalent. Actually, that's not right. Pi over 6 would be equivalent, not 2. Sorry. Be 1/2. So it's just depending on the question. Like if you want to plug in degrees, then you need to make sure it's in degrees. Otherwise, it's going to be wrong, right? That's the only reason. Yeah, but you could always convert it by hand and then plug in whatever you like.
And that's only for pi?
It's only for radians, like pi over 2, but radians are all in some form of pi, but not all radians have a pi on them. Some might be, like, for example, if I were to do this, right? Pi divided by 2, this is a radian still. It's just in decimal form. So if I wanted to use that number, which represents pi over 2, I need to have it in radians.
Okay.
Okay. Yeah, let me show you the questions real quick. So these right here require at minimum a scientific calculator. So you got to plug in these in degrees, right? So it has a degree symbol. Now, these are radians, so you'd have to switch over when you do this. Just make sure you're in the right form before you do it. Okay. That's all we got to do. There's nothing to solve there. Number 11 through 15 is identities. So let's do a few of those. Those are kind of more algebra heavy. So let's start with 11. Use trig identities to transform the left side into the right. So they give us an identity that says it says tangent theta times cotangent theta is equal to 1. So you need to basically show why that's true using the identities. So here we go. Tangent theta cotangent theta is equal to 1. So what you do first is use the quotient identity that I gave you at the beginning. Change tangent. Actually, what you should do first is state what side you're starting on. So like on an exam, what I want to see is which side you choose. Of course, we're not, or they told you which one to choose, but I may not tell you. Both sides might be, it might not be a 1 over there, this one's obvious. But anyway, so I'm going to start here and then start using my identity. So this is sine theta over cosine theta times cotangent is cosine theta over sine theta. So notice how these will divide out when you multiply, leaving you with a 1. So this property that we used was the quotient identity or property. And then this is just algebra. Is there any questions on how we show that it is indeed equal to 1? Okay, so not too bad. So you have a bunch of these. So since it's the first section talking about identities, it's not going to be too crazy. There'll be like a couple of steps and things will cancel. Maybe you'll add some fractions, but let me show you how they look like in the homework so you have an idea. So what they want you to do on paper is a little easier, but here they want you to actually plug in the first step. So they want to see how they tell you that this is sine over cosine. And they want you to plug in what this is going to be, because this cotangent is cosine over sine, like we wrote on the paper. So they want to see, do you know what the identity is? Over here, same deal there. You have tangent times cosine. So they have you change the tangent as sine over cosine. So that's the answer there. And this cosine is right here. And then you show the cancellation and you end up with just sine. So that's pretty much it for 11 through 13. 14 is slightly different. Let's do another. Let's do that one just for fun. So same instructions, right, as number 11. 1 plus sine theta times 1 minus sine theta is equal to cosine squared theta. So when you do these on your own, you kind of have to decide, all right, what side do I start with? Usually you want to pick the most complicated part. But in this question, again, they told you to start with the left. So we're going to start with the left. So do you see that this is a difference of squares, right? The conjugate pair. Or you can multiply it all out and then see that anyway. But just a little note here. We should remember from algebra that a plus b times a minus b is always going to be a squared minus b squared. So I have an a plus b times a minus b. So that the answer will be the 1 squared minus the sine squared. So 1 minus sine squared theta has an identity, right? What is 1 minus sine squared equal to?
Cosine squared.
Yeah, so the formula says, so we'll started here, so equals cosine squared. Any question on this one? Okay. One second. Okay, so let's move on to something else. You guys have the unit circle that I sent you? I'm gonna send it again right here in the, just in case. So the next couple of questions are, I believe, unit circle questions, but in reverse. They want to know which angle gives you this value. So check it out. So they want to know what angle theta gives you a square root 2/2. So remember, what I want you to remember is the x value here. This is x and y coordinate point, right? X, 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 y is on the right side. So when you're referring to cosine, you look at the x value, okay? So cosine of cosine of pi/4 or 45 degrees gives me an x value of square root 2/2, right? That's how you read this, in case you don't remember. So cosine of 30 degrees or cosine of pi/6, which is the same thing, that would be square root 3/2, the x value. Now, if we did sine of 30, that'd be the y value, which is 1/2. Sine of pi/4, square root 2/2. Sine of pi/3, etc. You see how it just keeps going the same thing all the way around. Okay. And remember how I told you to write down the pluses and minuses, and this is one of the reasons because it's going to be important later. Each quadrant, positive for both x and y, negative for x, positive for y over here, and so on. So go back to our question. You would just say, well, in degrees, it would be 45. And the circle told us that in radians, it was pi/4. And tangent's a little bit trickier because remember, tangent is a quotient, right? Sine over cosine. So you'd have to look at, look for an angle that creates the same thing, right? A little harder, but not really. So if I divide square root 2/2 by square root 2/2, you get 1, right? That's the only, one of the few angles that you're going to get 1. So it has to be here because if you divide these two, that's not going to be a 1. None of these will be 1. Only at the 45-degree angles right in the center do you have values that are the same. Although over here you have a negative and a plus, meaning the tangent of this angle would be negative. Tangent of this would be negative. Tangent of this is positive because they're both positive. Tangent of these two, right? Because the quotient would be sine over cosine. Since you're dividing two negatives, they would also be positive. So these right here are positive. So you would say pi/4 because the instructions tell you. It tells you it has to be between 0 and 90 degrees or 0 and pi/2. So that's why it has to be these two. Okay. There's not much work to show. You just need to look at your circle and find them. Okay. The same thing for these. So I'll leave those to you. You have any questions, guys, on using the circle?
Can you explain the tangent thing again?
Yeah, sure. Let me
Thank you.
show you a little bit more steps here. So they're saying for tangent theta is equal to 1. So they're wondering what angle does that? But you should also think of it as sine theta over cosine theta equal to 1. So when does that happen? So that would mean that both sine and cosine would have to be equal in order to get a 1, right? So it has to be, and they told us I can only look from 0 to 90 degrees. So here's 0 degrees, here's 90. So I have to look inside here. So when is sine and cosine the same? There's only one spot, 45. Does that make more sense?
Yes, sir. That makes more sense.
Okay. Alrighty, so you have a couple of those in the homework. Let's do 18. Find the exact values of X and Y. So they give us a triangle missing but missing both sides. So we have an X and a Y missing and a 14. They do give us this angle of 60 degrees though. So we need to use the trig functions to help us out. The definition of sine theta is opposite, right, over hypotenuse. So just solve for y, right? I mean, solve for, oops, I forgot. That should be sine 60, not sine theta. But you get what I'm saying, right? So sine of this angle is equal to the opposite over hypotenuse. So multiply both sides by 14 would get us here. And if me skipping some algebra steps confuses you, please let me know. I skipped one step from here to here. Is that okay? Or no? Is that weird?
I appreciate more steps.
Okay. Yeah, I usually add more, but I think I'm getting tired. I'm sorry.
Sorry, sir. I'm not as skilled at the math as you.
No worries. We'll get skilled together, right? We're skilled. So if we show the work, right, multiply both sides by 14, because I need to isolate that y, right? That's the goal. So this will be gone. So now 14 sine of 60 degrees is equal to the y that's missing. So now we just punch it in our scientific calculator. Make sure you are in degrees, otherwise it will be wrong. 14 sine of 60. I think I'm in degrees. Yes. So this will be 12 point, round to, did they say? Ooh, actually, they said use exact values. So I cannot use my calculator. So let's use our circle. So please open your circle. What is sine of 60? Let's see, where's mine? Right,
Square root 3/2.
for sine of 60, yeah, there it is, you're right. So 14, let me switch over in just a moment. So we just replace sine 60 with square root 3/2. Right? Let's multiply this through and we'll have 14 root 3/2 equal to y. 14 reduces with the 2, giving us 7 root 3 for my y variable. Right? Any of the steps confusing or strange? Did okay? All right, well, I'm gonna fill in for x now then. So I'm gonna use cosine of 60. That would be equal to adjacent over hypotenuse. Do the same thing, multiply both sides by 14. Fourteens will cancel. So now I have 14 cosine 60 equal to x. What is cosine of 60?
One half.
Yeah, 1.5. So put a half there to replace the cosine. And we're almost done. So what is half of 14?
7.
Yeah, right. Here it is. So now we can answer the question, right? So we got x equal to 7, y equal to 7 root 3, which is the same as a coordinate of 7 comma 7 root 3. So you have a couple of questions like this where they give you a triangle, an angle, and some missing pieces. So you're gonna have to choose, do I use sine, do I use cosine, do I use tangent? So that'll be what you have to practice and get used to. Like, okay, what is the missing part? What can I use to solve it? So the thought process here was I need to use something that has a hypotenuse. So I chose sine and cosine. Because if I would have chosen tangent, right, I'd have two missing pieces, and that wouldn't be helpful at all. Because you can't solve two unknowns with one equation. So I purposely chose sine because I knew it'd be y and 14. And I'd only have one missing variable. I know the left side, I know the bottom part. Same thing here. I know what there's a 14 there. I know this is some number. So I'll solve for x. Does that make sense? The thought process.
Do we have to memorize that circle?
No, I won't do that to you. I mean, they made me memorize it, but you do not have to. I would like you to have the circle with you at all times. Like I would print it out if you can, or draw it out either way. And then have one page front and back of formulas, just no examples for any exam. So you're allowed, just always bring your circle with you. Okay. One moment, let me find another question. All right, so the next one will be a word problem, and I think we're almost done with section. Yeah, I think that's pretty much it. We'll do one word problem and maybe we can call it a night and stop at section 6.2, and I'll see if you have any homework questions. So number 20. I'm gonna copy paste this into the, well, I'll write it for you. I'll write it. Okay. So number 20 is you are standing 42 meters from the base of a building. From the base of the or the whatever of the building. Who cares? Should have said A, but you estimate that the angle of elevation to the top of the 86th floor is 82 degrees. If the total height of the building is another 127 meters above the 86th floor, what is the approximate height of the building? I'll also copy paste it into the chat box. I don't know if it'll come out or not, but all right. So there's the question. So we should draw this out because I'm better than imagining this whole thing, right? So let's say you're right here. And you're standing 42 meters from the base of a building. So from here, let's say there's some building up here, right? Whatever. Let's say the 86th floor is right here. For some reason, you're really curious about this floor. I think that's an observatory or something. Who cares? So you look at this, you look straight at this window here. And there is, according to the problem, you estimate it looks like an 82-degree angle of elevation. So elevation meaning I'm looking upward, right? Okay. Then they said from here to here, there's an extra 127 meters, right? That's what they said. Yes, agree with me so far?
Yep.
Okay. And they said that from the building I am, or you are, 42 meters. So that's this distance here. So I can find this missing side by using a trig function and this angle. Which function should I use? Sine, cosine, tangent. We have 6 to choose from. What side is missing?
Tangent?
Yeah, tangent would work. Yeah, tangent's a good one. Because we're missing the opposite side and we have the adjacent, right? So opposite over adjacent is definition of tangent. So tangent of 82 degrees is equal to some opposite side, I don't know what it is, over 42, correct? Do you see where that came from? So then do some algebra and solve for tangent, 42 on both sides to cancel like we did last time. So now I know that the opposite side is equal to this. So now it's calculator time. Guys, okay so far?
Yep.
So this is about 200, right? So the opposite side is about 298 point. So round to how many? 1 decimal place. 8 meters. So this is 298.8 meters. So what's the total height?
Four 25.8.
Yeah, that sounds right. 425.8 meter. Let's show the extra step, I guess. So add the one we found plus the 125. That's all you got to do. 298.8 plus 127 equals to 425.8 meters. Any steps that did not make sense or were confusing? So you see how you can use the trig functions to do all kinds of things, right? So this is the question I was doing. So all you gave me was a paragraph. So I had to choose what trig function, and that is determined by what size of the triangle I'm given. So you have to draw it out. That's what we got, right? And then part B says one of your friends is on the 86th floor. What is the distance between you and your friend? Well, that would be the hypotenuse, wouldn't it? Right, if your buddy's right here at the window, it'd be the distance from here to there, which is hypotenuse. So you just do the Pythagorean theorem. That's it. A squared plus B squared. Go C squared and square root that guy and you'll be done. The hard part is this part. So you guys okay on 20?
Yes, sir.
Yep.
Alrighty, you'll have probably one more, maybe one or two more word problems, and that'll be it for the entire homework. But you guys have any questions on 6.1, or you guys doing okay on that homework section? I guess, well, if you have no questions, you're welcome to head out. And if you want to stick around and do a little homework, you can. That's all I have for you for today.
Thank you, sir. Have a good night.
You too.
I have to work at like 5 in the morning.
Oh, man, I'm sorry. That's horrible.
I know, hospitals, man.
Oh,
Night.
shoot. All right, take care. Get your rest.
Do have a question.
Mhm.
Do we have to factor cubic polynomials on the test, or was it just for the homework?
I don't know if I don't think it'll come up, but I'll check. Ask me again when we get close. I'll look at the exam and let you know, but uh, you just use your formulas. That's all you got to do, but
Okay, sweet.
I don't think it will be, to answer your question.
I'll ask again when it comes close.
Yeah, please do.
Thank you. Have a nice day.
All right, see ya.
Sir, when are we meeting, like in person, or are we still gonna do this
It
online?
looks like we're meeting Tuesday. So I guess what's it called? Yeah, we'll meet on campus in the class that's on your schedule. And starting Tuesday, keep checking your email. Monday we'll be sending a bunch of information on like what to do, how to. They're gonna have a bunch of requirements like checking in and all kinds of stuff. It's gonna be annoying, but yeah, you'll know on Monday all the details.
Okay. Are you gonna do like you know how you record these videos when we meet, or are you gonna like record in case we wanna like view the notes again, or?
Yeah, I'm gonna try to keep recording from now on. I'm gonna bring the camera with me to the classroom.
Okay, that's good.
Yeah, no worries.